Hello friend, in this video we're gonna design an inverting amplifier so that our output voltage is X time the input voltage. In previous video we have seen how to design the non-inverting amplifier, and I'm gonna put the link of that non-inverting amplifier in the video link comment section. And after the derivation we're gonna also see a multisim simulation. So let's start with the circuit. We have a simple amplifier. It has a 3 pin. This pin is the output. The output voltage we put EO. There's a negative and positive in. The negative is in for the inverting and positive is for the non-inverting. So since we are doing inverting amplifier, I'm connecting the positive in with the ground. The non-inverting in is connected with the input source EI. And for controlling the amplifier we need a input register and a feedback register. So that's how R1 and R2 are connected with the negative in. R1 directly connects to the negative in, and R2 connects the negative in with the output in. Before we start our derivation, we have to know that for ideal OpAmp, operational amplifier, it is assumed that the voltage on the non-inverting end is equal to the voltage of inverting end. So V at point A, voltage at point A is equal to voltage at point B. And we also assume that the negative in and positive in is kind of shorted, so the current is also same, EA and IA equals to IB, and the impedance of the amplifier is very high, so there's no current. Actually, there's a very small amount of current goes through, but we're going to assume that the current that is going through the amplifier is 0. So if that's the assumption, then start with Kirchhoff current law at point A. We can assume that the current going in, I1 is equals to I2 plus IA, the current going out. Let's talk about the direction. I think I did not talk about that. So the current direction, I took it from the source, it's going through the resistor R1, and then from point A it is splitting up at R2 and IA, and IA is almost 0. So for Kirchhoff current law, I'm going to put IA equals to 0. That means I1 equals to I2. Now from here we can put we can apply the Ohm's law. So voltage difference over the resistor. So the voltage at RA, point A, over the input voltage over the R1, resistor R1, output voltage VO minus the input voltage VA for R2. So if we plug the actual value, voltage at VA, point A is 0. Why is that? Since the ideal condition is that voltage at point A is equals to voltage at point B, since point B is connected to the ground, that means voltage at point B is 0, that means voltage at point A is 0. And that's why we're putting the voltage at point A is 0. That means the and voltage VI is the input voltage EI, voltage O is the output voltage EO, and we have the resistors. If we just make simplification, EO over EI, so output voltage over input voltage, will lead us to the negative R2 over R1. Negative sign indicates is that it's an inverting amplifier, and this the ratio R2 over R1 is our gain. So if we want a X amount of gain, which could be a 1, 2, 3, 4, 5, any value X. So if we want the output voltage to be X time of the input voltage, the gain would be minus R2 over R1, meaning R2 equals to XR1. So if our feedback resistor is X time, then the input resistor, the gain will be X times. So now we're going to see a simulation. So in our previous video, we have drawn a non-inverting amplifier in Multisim. We're gonna now draw a inverting amplifier in Multisim. So we are selecting an amplifier, simple amplifier. Now I have this in as my output. Since it's an inverting amplifier, I have to connect an input source. So I'm taking the AC voltage input source as that has to connect to the negative end. So I'm gonna connect my negative end here, and I also need a input register and output register. So actually I need to put a register in between. I'm gonna put this one a little far and a register in between and a feedback register here. Okay, so now I'm gonna connect those. My input voltage goes to the register, and from the input register it goes to the negative in. Since we're doing inverting amplifier, I also need a feedback register. That's why I'm connecting this pin, the output pin, to the this register, and this in gonna connect at this point. So my R2 is my feedback register, R1 is the input register. Since I'm not using the positive pin, I'm just gonna connect that pin with a ground. So I'll just put a ground here, and I'm connecting it with the positive end. And that's pretty much it for our oh, I also need to ground the source, so I'm just gonna ground him. Okay, so now you see that my R2, the feedback resistor, is 1 kilo ohm. I'm gonna change the input voltage to a value. So if you double click and you can change value, say I'm gonna do 3 volts. So that's my input voltage, 3 volt and 1 kilohertz. I'm gonna measure the voltage from my input and also measure the voltage. I think I didn't put it right, so I'll just put in one that is at that point. Okay, and this voltage is at the output of the amplifier, so at that point. Okay, so now see the output. If we can see the graph, now you see that the voltage is inverting. So if I pause and split it, so you see the green one is the input voltage and the blue one is the output voltage, and they are inverted. So you see the green one is going up, blue is going down. And if we look our derivation of inverting amplifier, that the gain depends on the ratio of the R2 over R1. So in our case they are the same, so the gain should be same, and that's what we got, that the voltage, input voltage and output voltage are the same, but we have inverted the voltage. Now if you want to get a different voltage, say if I change the R2 resistor by 2K, what happens? If we run it, now you'll see that it has changed. And if we pause it, now you see the input voltage still remain the 3 volt, but the output voltage went up. And it's went up how much value. You can change it here from voltage. See if you want to put -6 to +6 and plot it and zoom in, so you can just do that. Now you see the output voltage, which is the blue, is 6 and the input voltage is 3. That means we have made a gain of 2, and that's by the derivation we had. The if the feedback resistor is R2, which is twice than the input resistor, your gain should be 2. So we have amplified our input voltage by 2. So thank you.